Hi, my name is John. I'm going to be doing a calculus problem for you. This one's a little bit difficult. It's usually reserved for the BC students, if you can see it right there. And the mathematics is horrendous on this. I started working the problem out with one of my students, and it probably is going to take me a little bit of time to do it, so I decided not to do it and YouTube it for you guys. So if you want to take a look at it, it's the integral of e to the ax times bx dx, where a and b are constants. Okay, so you have a value of a right here, you have a value of b right here, and those are going to be constant because we're integrating, not differentiating, integrating with the value of dx. So the x is going to be the variables, e to the ax right here, and sine of bx. The first thing, I tried it both ways. It took me a little bit of time to actually work this problem out, and I could have called this the integration by parts. I could have set this as u and set this as dv. Took a little bit longer to figure it out, so I'm just going to rewrite it. Integral of the sine of bx times e to the ax dx. Okay, and that's your u right there, that's your dv right there. So we're going to let u equal to the sine of bx, and so the derivative of that is going to be, the derivative sign is cosine, and the chain portion bx is going to come out to be a b, so it's going to be b times the cosine of bx dx. So there you have it. U sine of bx, du is b cosine of x dx. And then we're going to let dv equal e to the ax dx. We're going to integrate both sides. The integral of dv is just v. Integral of e to the ax is 1 over a, e to the ax. And if you're not quite sure about why this happens, if you differentiate this, e to the ax, where the x is in the exponent, it becomes e to the ax times a, and that should cancel with the 1 over a, and you should end up with e to the ax dx. So take a little bit of practice and make sure that you get the chain portion down on the derivative and the integral. Okay, so the integral of u dv is equal to u times v minus integral of v du. That is the integration by parts. It comes from the product rule. So that integral of e to the ax sine of bx dx becomes u, which is located right here, sine of bx times v, which is 1 over a, times e to the ax, minus integral of v du. v located right here. I'm going to factor out the minus 1 over a right there, and du, there it is right there. I'm going to factor out the b, so it becomes b over a. These are all constants, so they can come out of the integral. It becomes e to the ax times the sine of, cosine of bx dx. And there you have it so far. Okay, cleaning the left side up just a little bit. That becomes, that's a constant right there, so I'm going to take that out. It becomes 1 over a times the sine of bx times e to the ax minus b over a, and I'm going to rewrite this as in this form right here. Integral of cosine of bx times e to the ax dx. Again, we're going to let this, we have to integrate by parts one more time. So that becomes u, that becomes dv. So let's rewrite it. U equal cosine of bx. So du is equal to, take the derivative of the cosine, becomes a negative sign, times the derivative of the chain portion of bx is going to be just b. So it's going to be negative b sine of bx. And dv was this portion right here, e to the ax dx. We're going to integrate that, the left side and the right side. V is equal to 1 over a e to the ax again. So the left side of the equation, I'm going to just rewrite this portion right here, okay? And it's going to take a little bit extra space. Now I'm just going to rewrite it as this ditto right here, okay? This portion is that ditto portion. It's equal to 1 over a sine of bx times e to the ax minus b over a, and then times the quantity. Integral of u dv is u times v, cosine of x times cosine of bx times 1 over a e to the ax. So I'm going to factor out 1 over a. Not factor out, just factor that first, that's a constant, times cosine of bx times e to the ax, and then minus integral of v du, minus integral of v du. So v is 1 over a, du is right over there. Notice that there's a minus. I'm going to put the b in the numerator, a in the denominator. It's going to be plus now, b over a. I can stick it inside or stick it outside of the integral, it doesn't really matter. I'm still going to get b over a, sine of dx, e to the ax dx. Now on the right hand side of the equation, I'm going to distribute this minus b over a out. It's going to get a little bit messy. So that becomes 1 over a sine of bx e to the ax minus distributing b over a with the 1 over a, I get minus b over a squared cosine of bx e to the ax, and then I'm going to distribute the minus and the plus, I get a minus again, b over a times b over a is b squared over a squared times the integral of e to the ax times sine of bx dx. Sorry about that. Now, what we notice is that e to the ax sine of bx, you end up with e to the ax sine of bx. So I'm going to move this term to the left side of the equation. The way I'm going to do that is I'm going to add b squared over a squared integral. If I add this term to the left side and add it to the right side will cancel. So I hope you've got everything so far, or put it on pause. So on the left hand side of the equation, if I add it, I get integral of e to the ax sine of bx dx plus b squared over a squared integral of e to the ax sine of bx dx. Now you notice that there's one of these and b squared over a squared term, so we can actually factor out the integral of that. I don't care about the right side, I can rewrite that a little bit later, just the right side. So when I factor it out, it becomes integral of e to the ax sine of bx, and then I'm going to have one of these left, plus I'm going to have b squared over a squared equals whatever the right side was. I'm going to refer to it back here, that portion right there. That's the right side. Okay. Multiplying, getting into one simple radical, one simple fraction, that's the same thing as, I'm going to put this in the front, a squared plus b squared over a squared. That's the same thing as these two partial fractions into a single fraction, because I just put a squared over a squared times the integral of e to the ax sine of bx dx. Sorry, if I had to put dx right there. Should have been over here. That's equal to the right side, whatever that right side was. Solving for this was the original problem right over here, so that's what we're trying to solve for. I have to get rid of this factor on the left side. I'm going to multiply by the reciprocal. So that becomes, on the left side, e to the ax sine of bx dx is equal to, multiplying by the reciprocal on the right side, I get a squared over a squared plus b squared times, now I'm going to rewrite this equation that was here previously, 1 over a sine of bx e to the ax minus b over a squared cosine of bx e to the ax. You notice there's one little thing that's common to both, e to the ax right over here. So I'm going to factor that out. I'm going to multiply by e to the ax right over here. And in the orange, I'm going to distribute just the a squared, because the answer in the back of the book came out just a little bit different than what I had here. So when we factor out e to the ax on the right hand side, the first factor, I get e to the ax on the numerator, and I get a squared plus b squared. When I multiply a squared by 1 over a, I just get a, and then times sine of bx minus, I distribute the a squared with that one, it cancels, minus b cosine of bx. That was the answer in the back of the book. It was a really difficult problem. Actually, it took me about only 12.5 minutes this time to solve it out, but usually it takes me if I had to slow down, because I worked it out once before, twice actually, it took me about 20 minutes to actually figure it out the first time. Lots of algebraic manipulations, okay? Next problem that I'm going to be doing is, we're going to do problem number 27. Oh, by the way, this was page 521 of James Stewart's book. Okay, I believe it was A New Horizon. That was one of his first books. 27. We're going to integrate x cubed e to the x squared dx. And I took a few minutes to try to work out this problem, so ahead of time it was a little bit difficult in that when I made the use of the substitution, it came out not quite expected. So what we're going to do is we're going to let this become u, and this becomes dv. So u is equal to x cubed. The derivative of that becomes 3x squared dx. Let e to the x squared dx equal v, dv, I'm sorry, whoops. And so we integrate the left side, integrate the right side, get v equals, I don't know how to integrate this because the chain portion x squared, there is no x right there, and that's why I had a bit of a problem.